Before proceeding with the installation, configuration, operation, or maintenance of these products, please ensure you have thoroughly reviewed all relevant documentation provided by Balluff and other pertinent sources, including installation guides, configuration manuals, and operational protocols. It is essential for users to adhere strictly to all applicable codes, laws, and safety standards during installation, wiring, adjustment, and operation. Installation, configuration, use, assembly, disassembly, and maintenance of these products must be performed by individuals who have received appropriate training and are fully versed in following the outlined procedures and safety measures. Failure to comply with these prerequisites may result in noncompliance with legal and safety standards. We expressly disclaim any liability or responsibility for damages, whether direct, indirect, special, or consequential, arising from the use or application of the information contained herein. Balluff Inc., in no event, will be held accountable for any damages incurred as a result of using this guide. The content of this guide is intended for illustrative purposes only and does not ensure suitability for specific applications due to the diverse range of variables and requirements in different scenarios. Users are entirely responsible for verifying the applicability and safety of this information for their unique situations. Acceptance and use of this information come with an understanding that any and all risks associated with the installation, configuration, assembly, or use of these products are fully assumed by the user. Please note that this document does not serve as a warranty of any sort, nor does it modify or supplement any valid warranty provided by Balluff Inc. for these products. The information herein supplements the original warranty terms without altering them.
In this video, we will go over configuring the parameter server in the Balluff Black and Silverline IO-Link masters in Rockwell Studio 5000 software. The advantage of using a Balluff IO-Link master is the built-in parameter server that's on the module. When this feature is set up on the IO-Link master module, this enables plug-and-play device replacements without needing to use a configuration tool or needing to manually set up the IO-Link device. The parameter server on the Balluff module stores the IO-Link device's configuration data in its non-volatile memory. The Balluff IO-Link master first verifies that the correct IO-Link device is connected to its IO-Link port, and if so, it then pushes the stored configuration parameters onto the IO-Link device. The configuration is done on the IO-Link master side through the PLC controller. This way, the PLC manages the parameter server on the master module, and it stays with the PLC program. When this is set up correctly, this leads to reduced downtime when replacing a failed IO-Link sensor. Simply, you can plug in a new identical sensor into the IO-Link master module, and the sensor's parameters are sent into the sensor itself automatically. Our setup will consist of using a Balluff Blackline IO-Link master communicating to a Rockwell PLC controller. Attached to port 1 of the IO-Link master module is an IO-Link sensor. Using Studio 5000 software, we can configure the parameter server that's on the Balluff IO-Link master. This example shows the Blackline BNI00KH IO-Link master module, but the setup is still the same for any Balluff Blackline or Silverline master module using Studio software. In Studio 5000 software, we have already configured the communications between the PLC and the Balluff IO-Link master module. The add-on instructions for both the sensor and the Blackline IO-Link master module has already been imported into Studio 5000. Once this is imported and our tags are created, we want to go into the mapped BNI tag of the IO-Link master module. When we right click on it, we could select monitor to go into this value. Inside our map tag is the input array, the output array, and the configuration instance array. We want to expand into the configuration. Inside the configuration array, we would see pin 2 and pin 4 map configuration. Pin 4 has already been set up for IO-Link enabled mode. After the pin configuration comes the validation and the parameter server for each individual port on the IO-Link master module. In this example, we'll look at port 1 along with the device that's plugged into port 1. First, we must set up the initial value of validation backup to a value of 3. This sets up the backup and restore of the module. By default, a value is 0, meaning no validation or parameter server has been disabled. For validation only for the IO-Link device, you can use a value of 1 or 2. A value of 1 is for an IO-Link 1.0 device. A validation for an IO-Link device that's IO-Link revision 1.1, you would put in a value of 2. Setting a value of 3 sets up the parameter server to be backed up. Once the value of 3 is put in, we would have to make sure that the correct IO-Link device is plugged into the port. In order to do this, we have to put in the vendor ID 2 bytes for the IO-Link device, as well as the device ID, which consists of 3 bytes of the particular IO-Link device. The IO-Link device properties can be checked using the web server on the Balluff IO-Link master. To do this, open up a web browser and type in the IP address of the Balluff IO-Link master module. Select on the port that you want to configure. In this case, it's port 1. Under General Information, the IO-Link device properties would show up. In this case, you can see the vendor ID we want to put in is 888 decimal or 0x0378 in hexadecimal. The device ID is 0E0102. So these are the values that we have to put in under device ID and vendor ID. Here, under style for the vendor and device ID, we can put in hex, so it's easier to input. So again, your vendor ID, your first byte would be 03 in hex, and then byte 2 would be a 78 in hex to match up to the IO-Link device. Device ID can also be put in as hex, and your device ID would be E0E01 and 02. Cycle time can be left at 0, which means that it's the fastest update rate. So in this case, after this is done, we want to save. We'll get a prompt that asks us to update the values to the project, and you want to select yes. Then this updates the values into the IO-Link master module. The configuration is only sent upon power-up of the module or when the Balluff IO-Link master is first connected by the PLC. So in this case, what we want to do is cycle power on our IO-Link master module. Once power is back on the module, the parameters on the IO-Link sensor has now been backed up and stored on the IO-Link master module. To verify this, we can open up the web browser of the IO-Link master module. When we open up the web browser, we can go into settings, then select ports, and we can see now that port 1 shows that validation and backup is set up as we set up in our PLC. The device ID and the vendor ID also matches up to what we set up in our configuration instance in the PLC. For the other ports, which we have not set up yet, under ports 2, 3, 4, and 5, we can see that there's no validation or backup shown. We can also click on the sensor itself to read some of the parameters. So now if we go to Home and we click on our sensor, once the IODD file has been imported onto the sensor, we can select the IODD parameter tab. Under the parameter, for example, if we set up a process data profile for the sensor, we can read that in, and it's currently set up for vibration velocity. The device temperature config, for example, we can read that value back. Currently, the values are, it's a lower alarm level of value of 11, and it also then has an upper alarm value of 61. These are the values, for example, along with all the other sensor parameters that are uploaded onto the IO-Link master module. Our next step is to go back in to our PLC configuration to set up a restore. So once all the parameters are backed up and set up, we can then go back into our PLC. Under the configuration instance, we can set the validation back up to a value of 4 instead of 3. A value of 4 means that the parameter server restore is set up. Once this is set up, we want to hit save so that the values get uploaded into our project and our PLC. And then again, in order for this to take effect, we want to cycle power on our IO-Link master module. Now the IO-Link master module is set up so that anytime the IO-Link sensor itself gets replaced, it would write in those current sensor parameter values. We can verify that the IO-Link master module has been set up for a backup by going into the web server of the master, then going under settings and looking at their ports. We can now see that validation and backup has been set up for restore. This means that anytime an IO-Link sensor gets unplugged or plugged back in, or a new sensor is plugged in, those values would be restored to the previous backup that we had backup in the module. So now, if we go into our sensor itself and look at the parameters, we can go into our device temperature config. We could now change the value as an example. And if we're going to unplug the sensor, and then plug it back in again, and then if we go back and read our parameter values, we can see that the default values that were uploaded to the IO-Link master has been there and overwritten those values that we temporarily overwritten to. So in this case, if we were to plug in a different sensor into this port that does not match up to the vendor ID or the device ID, we can see that now the port, instead of being solid green when it's plugged in, along with the web server, it shows that it's the incorrect vendor and sensor, so the LED now flashes red. However, once the correct sensor gets plugged in, the LED now will show it solid green, and all the sensor parameters get written onto it.